Today, we are taking a bit of a journey. We're stepping back, way back, from the day-to-day noise.
Way back. We're aiming for the biggest story, really.
Exactly. We're looking at this profound, almost inescapable connection between your existence right now, and, well, the stars, the entire history of the cosmos.
And there's this underlying idea, this ancient, intricate rhythm that seems to govern everything.
It's a deep dive into, let's call it cosmic philosophy, but one that's really built on hard science.
Right. The science is the bedrock. Our sources today, they aren't so much about, listing data points. It's more about weaving together things we know for sure.
Like element formation.
Exactly. The formation of elements, how gravity works, all that stuff. Weaving it into this cohesive narrative. A story that's, frankly, pretty awe-inspiring.
And the central idea, the kind of thesis for today, is that the universe isn't just there. It's not static.
No, not at all. It doesn't just exist. It dances. That's the core concept.
It dances.
Hmm.
I like that.
Yeah.
Okay, so let's unpack that because that's the heart of it. I want you, listening right now, just to pause for a second. Think about that feeling. You know the one. When you look up at a really clear night sky.
That sense of scale.
Yeah, you feel tiny, right? Maybe even a bit insignificant.
It's a common feeling, almost overwhelming.
But our mission today, really, is to take that feeling and flip it. Turn it right on its head. We want to move from feeling small to realizing, deeply realizing, that you are, at the same time, infinitely connected to everything you see up there.
And that's the paradox, isn't it? Small and infinite. It can be tricky to wrap your head around at first.
Definitely.
But the research we've pulled together, it really suggests that the way the universe works, every galaxy spinning, every distant star flickering, planets in orbit, it's not just random bumping around. It's part of this grand, incredibly precise rhythm.
Like a cosmic choreography.
That's a great way to put it. A dance floor that's older than we can truly comprehend. And we're trying to figure out the steps, find the sheet music.
So, okay, here's the big question for you today. The mission statement, if you like. What if? What if your destiny, your own unique path through life, wasn't just some script written somewhere?
Yeah.
What if it was actually danced into existence by the stars themselves?
That's a powerful thought.
That's what we're exploring. This deep dive is about tracing those profound, maybe unseen threads that link you directly to that whole cosmic tapestry.
We're going big first, then zooming right in.
Right. Starting with the huge stuff, birth and death of stars, galaxies, and bringing it all the way down to the smallest parts of your life, the atoms in your body.
And by the end, the goal is to really show you where you fit, how you find your place within that massive ongoing flow.
Because you're already part of it.
Exactly. It's about recognizing that we're already dancing, even if we haven't heard the music yet, or consciously noticed the rhythm.
So where do we start to hear that music? Where's the origin point?
To start recognizing it, we absolutely have to go back, way back. Long before our solar system even existed, we need to look at the universe's most spectacular and most crucial performance, the birth and especially the death of stars.
Okay, let's dig into this. This link between the science and the bigger picture, the philosophy. We need to rewind the clock. What, maybe 10, 12 billion years?
At least, yeah. Before Earth, before our sun was even a flicker.
We're talking about the universe's first generation stars, right? The giants, the ones that acted as, the source calls them midwives.
That's a perfect term for them. These massive stars lived fast, burned incredibly bright, and then died in these, truly spectacular explosions, supernovae.
And this process is what our sources call stellar alchemy.
Exactly. It's the cosmic process that literally made complex life like ours possible. We usually think of stars like our sun, just steadily burning hydrogen into helium. That's the basic process.
Right, fusion.
Fusion, yeah. And if the star is big enough, much bigger than our sun, it keeps going. It fuses helium into carbon, then oxygen, nitrogen, building heavier elements layer by layer in its core.
Like an onion.
Sort of like a cosmic onion, yeah. But the really crucial part, the part that seeds the universe, isn't the life of the star, it's its death. The violent, spectacular end.
We're not talking about stars like our sun, which just kind of puff up and fade into white dwarfs eventually.
No, this is different. We're focused on the real heavyweights. Stars maybe 8 times the mass of our sun or much, much more. They burn through their fuel incredibly quickly on cosmic timescales.
Live fast, die hard.
That's basically it. And when they run out of fuel at the core, things happen incredibly fast. The core, which has become mostly iron by this point, can't support itself against gravity anymore.
And iron is key here, right?
Iron is the end of the road for normal fusion. Fusing iron consumes energy instead of releasing it, so the furnace goes out, essentially.
What happens then?
Catastrophic collapse. The iron core collapses in on itself in less than a second. It shrinks from maybe the size of Earth down to the size of a city, becoming incredibly dense.
Wow.
And then it rebounds. This creates a shock wave that blasts outwards through the star's outer layers. That's the supernova explosion, a Type 2 supernova.
An explosion so bright.
So incredibly bright, yeah. For a short time, maybe a few weeks, it can outshine its entire host galaxy. Billions of stars worth of light from one single dying star.
And this is the midwife moment, this explosion.
This is it. Because that blast doesn't just destroy the star, it scatters all those heavier elements that were forged inside it. The carbon, the oxygen, the nitrogen, the silicon out into interstellar space. These are the elements absolutely essential for life as we know it. They wouldn't exist otherwise. Not in abundance.
Okay, let's pause here because this is critical. We need to get specific. The early universe, right after the Big Bang, was basically just hydrogen and helium. Really simple, light stuff.
Overwhelmingly, yes. Maybe trace amounts of lithium, but nothing heavier.
So how does a supernova, this explosion, create things like, I don't know, gold or platinum or uranium, stuff that's way heavier than the iron core it started with?
Okay, this is where the alchemy gets really intense. And the rhythm becomes incredibly violent for a moment. Like I said, iron is the limit for normal fusion. Making anything heavier actually costs energy.
So you need different conditions,
Yeah.
more extreme.
Extremely extreme. You need conditions of almost unimaginable pressure and temperature, but just for a fleeting moment. This happens during the supernova explosion itself through a process called the R process.
Our process.
Stands for rapid neutron capture. Imagine the moment of the core collapse and the shock wave ripping through the star. An absolutely massive flood of neutrons is released, just an insane density of free neutrons flying everywhere.
Neutrons, the neutral particles in atoms.
Exactly. And these neutrons get slammed into the existing atomic nuclei, the iron, the silicon, whatever's there, incredibly fast. Faster than those nuclei can radioactively decay.
So they just keep absorbing neutrons.
Yeah.
Getting heavier and heavier.
Instantly, they soak up neutrons like sponges, ballooning in mass, becoming extremely heavy, highly unstable elements. It's only in that brief, violent fraction of a second during the peak of the explosion that elements like gold, silver, platinum, lead, uranium, all the really heavy stuff can actually be forged.
It needs that specific, intense violence.
It's the universe's ultimate, most extreme forge. And it only operates for milliseconds during these cataclysmic events.
Okay, my mind is slightly blown already, but here's where it connects back. This is where the vastness of space hits you on a personal level, because the sources really drive this home. This isn't just abstract cosmology. There's a direct, unavoidable atomic connection between that ancient violence and you right now.
This is the pivot point, the aha moment, where the scale shifts from galactic to personal. Think about the atoms that literally make up your body.
Okay.
The iron in your blood, specifically in the hemoglobin molecules carrying oxygen around your body right now. Where did that iron come from?
From one of those stars.
From the heart of a massive star that lived and died probably billions of years before our solar system even began to form. It was forged in that stellar core, then blasted out in a supernova.
And the calcium in my bones, holding me up.
Same story. Forged in a star, scattered by a supernova. The oxygen you're breathing, the carbon that forms the backbone of your DNA and cells, all synthesized inside stars.
Even trace elements, like the tiny bit of gold they say is in us, or silver.
Yep. Any element heavier than hydrogen and helium, basically. Every single atom of it was cooked up inside a star and then dispersed. It traveled across maybe thousands of light years of space, over billions of years, eventually getting swept up into the giant cloud of gas and dust that collapsed to form our sun and its planets, including Earth.
So, Carl Sagan was right. We are stardust. Not just poetically.
Literally. We are recycled stellar material. High-grade, complex stellar debris assembled into conscious beings.
That's humbling.
And it perfectly captures that rhythm the sources talk about. It's this constant, powerful cycle. Creation fueled by destruction.
A star lives, builds complexity.
For millions, maybe billions of years, patiently fusing elements, reaching that iron limit.
Then it dies. Violently.
And that death isn't an end. It's the critical step that scatters the ingredients needed for the next generation. The building blocks for planets, for atmospheres, for oceans, for life.
So the destruction is absolutely necessary. If those giant stars just lived forever or faded quietly,
The universe would still be mostly hydrogen and helium, complex chemistry, geology, biology, none of it could happen. The seeds of life, the raw materials were planted in the chaos of those explosions.
which brings us back to that core idea for this section. It's
It
profound.
really is. Every single atom that makes up your physical body, your bones, your brain, your breath, every bit of matter constituting you right now, it once danced inside the fiery thermonuclear heart of a star
Billions of years ago.
billions of years ago. And now, after that incredible journey across space and time, that very same matter, carrying that ancient stellar history, that fundamental cosmic rhythm, it dances within you, powering your thoughts, your feelings, your life.
You're literally carrying the history of the cosmos inside you. That iron atom's journey across the galaxy, waiting for its cue in the next act.
The act that became Earth, and eventually us.
Okay, so the ingredients are there, scattered stardust across the void. But how does that dust cloud, that debris, stop being just random floating stuff and become a home, a planet like Earth?
That's the next movement in the cosmic dance. From the ashes of stars to the formation of worlds, that's the perfect transition, yeah. We've got the raw materials, the heavy elements, the ashes from supernovae sprinkled throughout clouds of gas and dust in space.
The seeds are there.
Seeds are there. But now the challenge is, how does this random, chaotic mix of stellar leftovers come together to form something stable, ordered, like a planet? Specifically a planet like Earth, in just the right place for life.
This is where the pace changes, right? From the instant, violent supernova to something much slower.
Much, much slower. We're shifting from the millisecond timescale of a star's death to the millions of years timescale of planetary formation. This is where the next movement begins, what the sources call the planetary waltz.
A waltz implies order, structure.
Exactly. It starts with those vast clouds of gas and dust. We call them molecular clouds. They can be light years across, mostly hydrogen and helium, but enriched with those heavier elements from previous star generations.
Cold and dark.
Very cold, very dark, dense. And something needs to kickstart the process. Often it's a disturbance, maybe a shockwave from a nearby supernova, or gravitational nudges from other stars.
Some trigger.
A trigger causes a region within the cloud to start collapsing under its own gravity. And as it collapses, conservation of angular momentum comes into play, just like an ice skater pulling their arms in.
It spins faster.
It spins faster and faster, and it flattens out. The vast majority of the mass falls to the center, getting incredibly hot and dense. That becomes the protostar, the baby sun. The rest of the material forms a flattened, spinning disk around the central protostar. This is the protoplanetary disk. It's huge, maybe hundreds of times wider than the distance from the Earth to the sun.
And this is where the planets form, in that spinning disk.
This is the nursery. Within this disk, that planetary waltz really gets going. It's not just particles randomly bouncing around anymore. There's a harmony to it.
How does that work? How do tiny dust grains become planets?
It starts small. Microscopic dust grains, remnants from those stars, bump into each other gently. At first, they stick together because of static electricity, like dust bunnies under your bed.
Okay.
And maybe weak forces, Van der Waals forces. They form little fluffy aggregates. These grow, colliding and sticking, becoming maybe millimeter or centimeter-sized pebbles. Cosmic snowballs, basically.
Still tiny compared to a planet.
Oh, absolutely. But as these pebbles grow larger, gravity starts to take over as the dominant force sticking them together. They sweep up more material, growing into larger bodies, maybe kilometer-sized. We call these planetesimals.
Mini planet. Yeah.
Essentially, yeah, asteroid-sized building blocks. Now you've got millions of these planetesimals orbiting the young star within that disk.
Okay, now I picture chaos. Millions of asteroid-sized things whizzing around. Wouldn't they just smash each other to bits constantly? Destructive collisions.
There are definitely destructive collisions, lots of them. But here's where the waltz part, the choreography, becomes crucial. It's not complete chaos. Why not?
Gravity.
Gravity and the fact they're all orbiting in roughly the same direction within that flattened disk. Their orbits aren't random. They're governed by the star's gravity and their own mutual gravitational pulls.
So they're kind of moving together like lanes on a highway.
In a way, yes. Gravity acts as the conductor here. It keeps things relatively ordered. It leads to constructive collisions, too. When planetesimals collide at relatively low speeds, they can merge and grow larger.
And the bigger they get.
The stronger their gravity becomes, the more effectively they can pull in smaller objects and sweep their orbital path clean. It becomes a runaway growth process for the largest ones. These dominant bodies become protoplanets.
And eventually, planets like Earth.
Eventually, after maybe tens of millions of years of collisions, mergers, and gravitational sculpting, you end up with a few stable planets in well-defined orbits. Gravity has acted as both the choreographer and the dance partner, guiding this whole process.
So the sources say this wasn't just random chaos, but a carefully choreographed ballet. Gravity is the key.
It's the absolute key. It dictated where the planets formed closer in for rocky planets like Earth, further out for gas giants. It dictated their spacing, their orbital speeds, their tilt. If the initial conditions, like the cloud's spin or the strength of gravity, were even slightly different.
The whole system could be different. Planets crashing into the sun or flung out entirely.
Exactly. The stability we see, the fact Earth has stayed in this habitable zone for billions of years, is a testament to that precise gravitational choreography early on.
And the amazing thing is, the dance didn't just stop when the planets formed. It's still going on.
Absolutely. The planets continue in their eternal orbit, as the source puts it. This celestial waltz is happening right now, shaping the fabric of time and space around us.
And this leads to another really interesting idea from the sources. Cosmic memory.
Yes, this is fascinating. The idea is that every object involved in this dance, every planet, every asteroid, every moon, carries a kind of memory of that ancient formation process.
Okay, memory in a rock.
Uh,
That sounds a bit metaphorical.
hmm.
How do we ground that in physics? What is this memory?
It's not conscious memory, obviously. It's the physical imprint of its history, preserved in its current state and motion. Think about Earth's tilt.
The 23.5 degrees it gives us seasons.
Right. That tilt isn't just random. It's almost certainly the result of a massive collision early in Earth history, probably the collision that formed our moon. The angle is a physical memory of that violent event.
Okay, I see. The physical state is a record of past events.
Precisely. Or think about Earth's rotation speed, the length of our day. That's inherited directly from the angular momentum of the original spinning protoplanetary disk. Or the specific composition of Earth's layers, the heavy iron core, the lighter crust, that's a memory of the differentiation process when the planet was molten.
So the planet is constantly physically replaying the consequences of its own formation. Its current movement is the memory.
That's a great way to put it. The planet is remembering how it was formed through its ongoing physical behavior, its rhythm. And that rhythm, that ancient planetary waltz established billions of years ago, still affects us directly.
Like the tides.
The tides are a perfect example. Governed by the gravitational dance between Earth, Moon, and Sun, a dance set up by those early formation dynamics, that ancient rhythm is literally shaping coastlines, influencing ecosystems, even affecting biological cycles. We are constantly living within the echo of that billion-year-old planetary waltz.
Wow. Okay, so we have the ingredients from stars and the stage built by gravity's dance. What about the time scale, the sheer time involved? We've got the atoms, we've got the planets. Now we need to zoom out again, way out. To really feel our place in this cosmic dance, we have to grapple with deep time, the sheer age of everything.
It's fundamental. The timescale is almost impossible to truly internalize, but we have to try. The journey starts 13.8 billion years ago, the Big Bang.
The beginning of time itself, as we know it.
An explosion of, well, not in space, but an expansion of space itself. Unimaginable energy density. It's a number, 13.8 billion years, that we can say easily.
But feeling it is different. That calendar analogy helps if the whole universe's history is 1 year.
Then all of recorded human history, everything from ancient Sumeria to now, happens in the last minute or so before midnight on December 31st. Our entire existence is a tiny fraction of the last second.
When you put it like that,
Yeah.
it really highlights how much had to happen before we could even show up, how much cosmic groundwork was needed.
Immense amounts. It's the complete opposite of instant gratification. The universe is playing the long game.
And the sources use this vast timeline to show how the foundation was built layer by layer.
Exactly. After the Big Bang, the universe expanded and cooled. The first simple atoms formed hydrogen, helium. Then came a period called the Cosmic Dark Ages, before the first stars ignited.
Hundreds of millions of years of darkness.
Yep. Then those first stars switched on, lived, died, created the first heavy elements. Gravity pulled matter together, forming the first galaxies. These galaxies then merged, collided, interacted, dancing these huge slow-motion ballets across billions of years.
And the key idea here is that every one of those events, every galactic merger, every star's life cycle, wasn't just stuff happening randomly. It was essential for what came next.
It was laying the foundation, building complexity step by step. A colossal chain reaction of cause and effect, unfolding over cosmic epochs. You couldn't skip any steps.
Which leads to this philosophical point the sources make.
Yeah.
The universe is incredibly patient.
Infinitely patient seems about right. It doesn't rush. Think about it. It took maybe hundreds of millions of years just for the first gas clouds to cool and collapse into stars. Billions more years for enough heavy elements to build up to make rocky planets possible. Billions more for those planets to cool and stabilize.
That kind of patience is alien to us. We think in terms of lifetimes, maybe generations. The universe thinks in eons.
Completely different scale. And yet, and this is crucial, the sources argue that despite this immense
More complex structures over time.
that seems to be the interpretation. It's the necessary unfolding of physical law. From simple hydrogen atoms to stars cooking heavier elements, from those elements forming dust grains to those grains building planets, from simple molecules on those planets to self-replicating life. It's a consistent flow towards higher levels of organization and information density.
Driven by the fundamental rules of the game.
Exactly. And that purposeful flow, that patient building of complexity, continued for billions upon billions of years. Stars formed, died, scattered their ashes. Planets formed, cooled down. Oceans formed. The chemistry got more and more complex.
And the odds. The sheer astronomical odds against this whole sequence playing out perfectly over 13.8 billion years without some catastrophic interruption. It's mind-boggling.
It really is. All that deep time, all that patient unfolding, all those specific events happening in just the right way, leading eventually right here to this moment.
To us listening to this, the source material puts it beautifully. After all those billions of years, all that cosmic history, finally, in a relatively quiet corner of a spiral galaxy, our Milky Way.
On a small blue planet.
The stage was finally set. Everything was in place.
All the prerequisites met. The right elements, the right temperature, liquid water, stable orbit, protection from radiation. Check, check, check. Billions of years of preparation.
And then life emerged. Not with a roar, but as the source says, something fragile, fleeting, yet aware.
That emergence of life, and especially awareness, feels like the point of it all, in a way, the combination of that long, purposeful flow.
The universe spending almost 14 billion years setting the stage.
Just so that one day a species could walk onto it, look up, and begin to understand the very processes that created it. It's quite a narrative.
Okay, this feels like a biggest leap yet. We've gone from inert matter, stardust, planets, basic physics and chemistry. Now we had to bridge the gap to biology, to life. And not just life, but consciousness, self-awareness.
It's a huge transition. The universe provides the ingredients, the stable platform, the energy source. But how does non-living chemistry suddenly wake up, become aware of itself?
The sources describe the start of life very subtly. Not a sudden bolt of lightning, but whispers.
Whispers in the oceans, maybe in volcanic vents and wet clays. It likely started very small microscopically. The first self-replicating molecules, maybe RNA-based. The first simple cells, just membranes enclosing replicating chemistry.
But even then, the sources suggest these earliest forms carried a kind of spark of consciousness. What does that mean at such a simple level?
It's consciousness in its most basic form. Not self-reflection, but the ability to sense the environment and respond adaptively. To seek food, chemicals, avoid danger, harmful conditions, to replicate. It's a basic form of information processing and goal-directed behavior, a fundamental awareness.
Okay, so life gets a foothold. Then what? Then comes the explosion of variety.
Then evolution takes the stage, and over the next few billion years, it choreographs this incredible symphony of forms, as the source puts it.
A symphony, meaning a huge diversity of species.
Exactly. Driven by random mutation and natural selection, life constantly experiments, adapts, fills every available niche. The sources see every single species that has ever existed, from bacteria to archaea, from trilobites to dinosaurs, from ferns to mammals, as a unique step in the universal dance.
Each one a variation on the theme, an exploration of complexity.
Precisely. Each species represents a different way of solving the problems of survival, energy acquisition, and replication. Each one furthering that overall trend the universe seems to have, building more complex, more organized structures capable of processing more information.
But the really big jump, the one that brings us back to us, is the emergence of not just basic awareness, but the self-reflective mind.
Right. Moving from, say, a bacterium responding to a chemical gradient or a plant turning towards light to a brain capable of abstract thought, of remembering the past and planning for the future, of being aware of its own existence.
Knowing that you know.
Knowing that you know, that's the leap. The sources describe this as the moment the dance became conscious, the point where the universe, through a part of itself, could stop just being and start thinking about itself, observing, analyzing, understanding.
And that requires a pretty complex piece of hardware.
It requires the human brain, or something functionally equivalent. A biological system complex enough to model not only the external world, but also itself within that world. To look up at a star, analyze its light spectrum, and realize, hey, the iron signature in that star matches the iron in my own blood. That's a profound feedback loop.
We are the universe's way of looking back at itself, its mechanism for writing its own autobiography.
That's a beautiful way to put it. And this is where the sources propose perhaps the most mind-bending idea of all.
Okay, now braced.
That our minds, our thoughts, our subjective experiences, our dreams, our creativity are not just isolated phenomena happening inside our skulls. They are described as echoes of the universal rhythm itself.
Echoes of the universal rhythm.
Okay.
Wow. We need to unpack that very carefully. Is that just a metaphor, like our brains are complex, the universe is complex, so they're similar? Or is it suggesting something deeper, a structural connection?
The argument leans strongly towards a deeper structural connection. It's drawing parallels using insights from network theory, complexity science, fractal geometry. Well, look at the way things are organized. The neural networks in your brain, how billions of neurons connect, branch out, form these incredibly intricate layered webs to process information. They follow certain mathematical patterns, fractal-like patterns.
Okay.
Now, zoom out. Look at the large-scale structure of the universe. How galaxies aren't just randomly scattered, but clustered together in huge filaments and walls surrounding vast empty voids. This cosmic web, its structure, mathematically, shows remarkable similarities to the structure of neural networks.
So the way matter organizes itself on the grandest cosmic scales is similar to how our brain cells organize themselves to create thought.
The underlying mathematical principles, the rules governing how complex networks form and behave, seem to be astonishingly similar. The way information flows, the way structures grow and connect, it suggests a universality.
So the rhythm isn't just about cycles of stars and planets. It's embedded in the very architecture of complexity itself.
That's the idea. The fundamental rhythm that orchestrated the cosmos, the interplay of forces like gravity and expansion, the drive towards self-organization might be the very same rhythm that generates a thought, retrieves a memory, or sparks an insight in your mind right now.
Which implies
Yeah.
that consciousness isn't just some random accident, a fluke of evolution on one small planet.
It implies that consciousness might be a fundamental property of the universe when matter reaches a certain level of complexity and interconnectedness. Not an accident, but perhaps an inevitable outcome of that purposeful flow we talked about, the universe evolving a way to experience itself.
So when we look up at the stars and feel that connection, that sense of being part of something vast, it's not just sentiment. It's reflecting a genuine structural resonance, our inner world mirroring the outer cosmos.
That's the provocative conclusion. Our subjective internal life isn't separate from the objective external universe. It's a localized, highly complex manifestation of the same underlying universal process, the same rhythm. We are, in a very real sense, small-scale models of the cosmos, capable of reflecting on the whole.
We are the universe experiencing itself, the focal point of that 13.8 billion year rhythm, becoming aware.
Aware and capable of influencing the next step in the dance. Which brings us right to the idea of destiny.
Right. This is where it all comes together on the most personal level.
Right.
If we're made of stardust, literally, if our planet's formed through a cosmic dance, if our very thoughts echo the structure of the universe, what does that mean for our individual lives, our path, our destiny?
It's the ultimate question, isn't it? And to approach it, the sources first suggest looking back. This feeling of being connected to the cosmos, it's not new. It's ancient.
You mean like ancient cultures and astrology?
Well, yes. Think about ancient civilizations. The Babylonians, the Egyptians, the Mayans, countless others, they meticulously charted the stars and planets. And not just for practical reasons like navigation or agriculture timing.
We saw something more in them.
They saw mirrors, mirrors of their own existence, reflections of earthly events, omens, guides. They operated under the profound intuition that the movements of the heavens were intrinsically linked to their lives, their fates, their communities.
They felt those invisible threads connecting them to the sky.
Exactly. There seems to be this deep, perhaps innate, human sense that we aren't separate from the cosmos, but deeply interwoven with it, that the macro rhythm up there influences the micro rhythm down here. They instinctively felt they were part of one single grand operating system.
Okay, but let's bring that intuition into the framework we've built. How do the sources connect this ancient feeling to modern physics and philosophy? They talk about a ripple effect of being. What's that?
This is a concept that really ramps up the personal significance. It's the idea that you are not a passive observer in the universe. Every single thing you do, every choice you make, every action you take, even potentially every thought you have, isn't just contained within you.
It ripples outward?
It ripples outward, like a stone dropped in a pond, but the pond is the fabric of space-time itself.
Okay, that's a huge claim. How our thoughts are electrical impulses in our brain.
Yeah.
How do they ripple through the cosmos? Are we talking measurable gravitational waves from thinking?
Measurably. Probably not with current technology. The effect of a single thought would be infinitesimally small. But the principle connects back to fundamental physics. You have math, you have energy. You move, you act, you change the distribution of mass and energy around you.
And according to Einstein, mass and energy warp space-time. That's gravity.
Exactly. So by simply existing, by moving, by interacting, you are constantly contributing, minutely but undeniably, to the curvature of space-time, to the gravitational field. You are an active source of vibration, however small, within the cosmic medium. Your presence matters to the structure of reality.
So my actions literally send ripples, however tiny, through the universe. I'm not isolated.
You are fundamentally interconnected with everything else through the field of gravity, at the very least.
Yes.
Your existence is a constant interaction with the cosmic web.
Okay. If that's true,
Yeah.
then the whole idea of destiny looks different. It's not some fixed path written down somewhere.
No. The sources strongly argue against a rigid, predetermined script. Instead, they ask, could destiny be written in the movement of galaxies, in the continuous living rhythm of stars?
Meaning destiny is the flow. It's the dance itself.
Precisely. Destiny isn't a destination you're fated to reach regardless of your actions. Destiny is the unfolding process, the rhythm, the dance. And those threads of destiny aren't strings pulling you along, but the very fabric of space-time that you are woven into and that you are actively influencing with every step you take.
Wow. Okay, so that completely reframes it. Destiny isn't something that happens to you. It's something you are actively participating in creating moment by moment.
Yes. It shatters that sense of isolation, that feeling of being a tiny, insignificant speck tossed around by random forces. You are not separate from the universe trying to navigate it. You are the universe, locally embodied, participating in its unfolding.
You're a dancer in this cosmic choreography that stretches back billions of years. A rhythm that had to happen just so for you to even be here thinking about it.
Your life is nested within that immense, purposeful flow.
So then, every person you meet, every opportunity that comes up, every challenge you face, it's not random.
Viewed through this lens, no. They can be seen as the next step in this grand choreography. It's the universe, through its interconnectedness and causal chains, presenting you with the next movement, the next interaction, shaped by everything that came before.
The context for your next choice.
The context, the opportunity, the partner in the dance, if you will, and this leads directly to the final, really actionable insight from all of this.
How to live this.
How to live consciously within this cosmic dance. It means striving to move in harmony with that universal rhythm. It means, first, recognizing the rhythm, recognizing the echoes of stellar formation, planetary motion, evolutionary history, and network complexity that are already operating within you and around you.
Becoming aware of the music.
Becoming aware of the music, and then actively finding your own unique personal rhythm within that larger flow. Aligning your choices, your actions, your intentions with that deep, purposeful unfolding that stretches back 13.8 billion years.
So you're both listening to the universe's song and singing your own verse.
Beautifully put. You are receiving the melody passed down through eons, and you are contributing your own unique note, your own improvisation, to the ongoing symphony. The dance doesn't just happen around you. It requires your participation. Your movement shapes the future flow.
Yeah.
Hashtag tag retro outro.
Wow, okay. We've covered a lot of ground. Or maybe a lot of cosmos.
From the Big Bang to your brain, essentially.
Yeah. We started with those ancient stars exploding, forging the very atoms that make us up the iron in our blood.
Then we saw how gravity patiently choreographed the waltz of planets, creating our stable home.
We grappled with the immense patience of deep time, seeing a purposeful flow towards complexity.
And then the incredible leap to life, to consciousness, realizing our own minds might echo the structure of the universe itself.
And finally, seeing destiny not as fixed, but as our active participation in this ongoing cosmic dance.
The synthesis is, well, it's quite profound, I think. Destiny isn't some rigid sentence handed down. It's fluid, it's dynamic. It's like a melody being composed in real time.
Not for you, but with you.
In collaboration with you and with the stars and with the entire history of the cosmos.
And that word collaboration is key. It means you have agency. You have a role to play. It's not passive.
Absolutely not. Every choice you make, every action, every thought really does contribute something new to that universal symphony. You aren't just listening in the audience.
You're playing an instrument. Maybe one you didn't even realize you had.
Right. So maybe the next time you feel, I don't know, overwhelmed by complexity, or maybe small and insignificant looking up at the sky.
Remember this conversation.
Remember the final thought, the provocation from this deep dive. You aren't just the dancer or the dance. You are somehow, simultaneously, both.
The observer and the observed.
The wave in the ocean. You are the universe, right here, right now. Become self-aware and actively participating in the unfolding of its own incredible story.
So look up tonight. Look up at the stars. And remember, your story, your dance, continues. It's intertwined with the very stuff of stars. It's infinite, magnificent.
Find your rhythm. Keep dancing.